is a member of our faculty here at Auburn, and we're very fortunate to have him. You can see he's got more letters after his name than anybody else on our faculty. Rich got a degree in general engineering at University of Illinois and his PhD in mechanical engineering at University of Utah, and he specializes in safety and ergonomics, and I think a little bit of biomechanics. And he stayed out in Utah. He, for some reason, liked living where he could ski and do hiking and stuff for a while as a research professor, but we were able to entice him away 2 years ago, right? Time has flown. And he's a member of our faculty who specialize in occupational safety and ergonomics. He hasn't really been specifically involved and focused on material handling and logistics, but he certainly has done a lot of work with companies in that business, and we thought it would be a good aspect to include in our Teachers Institute to talk about the human part, especially the biology human parts opposed to the cognitive part. So without further ado, Rachel.
And what I'd like to do is, well, one, having to go after Leon and Kimberly is kind of rough, and that's not fair to me. But over the last couple of days and seeing the different presentations, I kind of morphed this a bit. And what I want to do is I got a lot of content, and rather than get rid of it, I hid some slides. I'll go over some of the slides. I've selected both. I'll cover the main concepts, but I want to leave you, I talked to Mike about this, leave you with a little bit more for the presentation. You can use it however you want. I want to talk about kind of the art of ergonomics, and I got kind of inspired after our tour of the art museum, so I'll show you a little picture here. Found a painting of the legend of John Henry, the steel driving man. Who knows the story, basically? Who wants to share? What's the basic gist of it?
He's racing a steam drill. Yeah. So he raced a steam drill with a hammer. They were driving these rods to blasting.
Depending on who you talk to, it happened in Alabama or it happened in West Virginia. I'll vote for Alabama. There actually was a guy named John Henry. There was actually a race, and there was potential. I assume this guy did pass away afterwards. At least that's the story, whether it's apocryphal or not. What is the lesson of the story of John Henry?
Your body can only take so much.
Your body can only take so much. Essentially, for those that don't know the story, they brought this vendor brought in the steam-powered drill, and he says, "I can beat a man," or whatever. And John Henry was this strong guy. He was the strongest guy out there. He was, at the time, this is in 1900, he was 6 foot tall and about 200 pounds, which was ginormous back then. Okay, we didn't grow him that big back then. He was an incredibly strong guy. He races this thing. He ends up beating it. He supposedly drove in like 12 inches of whatever, and the machine got 9 or whatever in a 12-hour day. And then he, like, some people think he had a stroke, whatever, he dies, right? Well, the lesson here, and it's kind of ironic, is there's a big labor movement kind of going on at the same time, and there's a kind of a competition between this guy. If you didn't have a job, it was pretty poor where he was at. It's pretty much like your death anyway. You can't take care of your family. You can't do things. He was basically racing for his life with this thing anyway. It was kind of the thing. But they turned it around. There's a ballad, there's a song, and people would sing the song at a purposefully slow pace. And the reminder was, you can only go so fast. Don't overdo it. You're just going to kill yourself. And so when these guys were doing this work, they'd sing out of John Henry, and they'd go at a certain pace. They'd set a pace. So kind of this kind of theme is we'll talk about a little bit here. And different presenters have talked about, when do you mechanize, when do you not mechanize, when do you do it by hand, how cheap is labor, and we'll talk about a few of those things. So kind of the outline that I want to go through is I want to talk about human factors, kind of the human side of material handling. We will talk a little about cognitive issues and physical. The human factors of teaching, some tips on active learning. I wanted to kind of include this because I think it's on psychology too. Alice was kind of it was the ADD student. I just kept going different directions. They all kind of make sense and add up at this point, I think, anyway. But a little bit about how to get across, and also to adult learners, which I think makes sense because some of us will be talking to people in warehouse to trying to educate people. And after about 10 or 12 minutes, what do? We start to, we whiplash, we start to fade. Some ways we can engage students. And I want to talk a little about the changing workforce and how that's going to impact, or how that could impact material handling. And then a little bit briefly on the art of ergonomics. So let's start with the picture. Which way is it to room 521? Is it to the left or the right? Who says left? Who says right?
Left.
Who says it's neither one? So what they do, this is a bad design. We look at this, they number them backwards. So like you're looking for 520, oh, it can't be here, it's not here, it doesn't make it to which way is it? And it turns out the room's counted down, and they were trying to help you, but they really didn't help you. And a lot of people read the first one and say, well, 521's not this way, it's 527 and above, right? And they just turn the wrong way. This is at a hotel. So this is just an example of human factors. Here's another one where, which way should you go? Should you go right or left? How many people say right? How many people say left? It's usually about 50-50. I like to bring examples. I like to bring at the beginning of class for students. And if you look at this, the sign is almost optimally bad because 50% say one way and 50% say the other way. Because at least if it was 70-30, you could flip the sign if you had to and at least get 70% of the people where you want. And I always ask my students, I say, well, how could you improve the sign? And people have different ideas. You could have two signs. You could have a line between the two, like don't go this way, go that way. Or you could put the prohibition symbol over the line, don't go whichever way you shouldn't go, and then flip the sign if you need to. Just an example kind of human factors. One thing I always like to do in my classes is throw in a so what slide. And I ask this question at every defense, and people sometimes take offense, like I just did my PhD. It's like, well, so what? What do you do with it? I was the outside reader for a math PhD. And Auburn has an outside reader, and you basically, you're supposed to kind of make sure as an objective person that science has been done and all this. And I asked a question. I said, I didn't say like, well, so what? But I said, so what are the practical applications? Oh my God, they must not have ever had an engineer in the math building, because it's like, did he just say, what do we do with this? And I think if I understand this group, and I think I got a pretty good idea, the questions you guys ask, what are the tools? How do I do this? I mean, you guys want to know what to do with it. And so I like to put this in. Well, one is we want to protect people's health. And I say sanity because if anybody's ever had an electronic device that you can't coexist with. I mean, in the 80s, every VCR was blinking 12 o'clock because no one knew how to set them, right? At least at my mom and dad, they never knew how to, oh, the power went out. Yeah, like a month ago. So, but how do we do these things? But improving productivity, quality, satisfaction, avoiding unnecessary delays and costs and hassles, reducing waste, making more product, or in the case of distribution, moving more product. In short, building better mousetraps. That's why we do ergonomics and human factors, hopefully. Now, one of the things that I found interesting is in Leon's talk, he talked about functions, and so I think, what's the function of safety? To provide constraints. He said, we have too many degrees of freedom. Well, we'll take some of those away. He said, an each is an each, except that an each has an intrinsic quality, and that intrinsic quality may have a safety factor. I may be moving flammable liquids. I may be putting my matches next to my firecrackers. I mean, it depends. My oxidizers next to my fuel gases, et cetera. So how do we do these things? We add constraints. And unfortunately, and that's a tough job. I've been a safety engineer at a plant. And that's what you are. You're the stick and the spokes of their bicycle of progress. It's all, and you got to try to paint in a way, how am I productive for you? So, it's kind of sad, but I'm a constraint. I teach people to be constraints. But at least I'm teaching women to be constraints, so Alice can be happy. We graduate a lot of women in safety, which is great, because I've seen over the last 20 years in safety, going to safety conferences, more and more female safety engineers, which I think is a good thing. So what are human factors in ergonomics? We all know this, but it's focus on human beings and how they interact both at work and everyday living. And we have certain expectations. We have population stereotypes. If I ask you guys to reach out and turn up the radio, you're all going to do clockwise. We have a principle, clockwise for increase. If we don't, people are going to be making that product's going to be rejected pretty quickly. A lot of people ask me, well, what's the difference between human factors and ergonomics? And a lot of people use the term synonymously. Originally in this country, it used to all be called human factors. In fact, the Human Factors Society became the Human Factors and Ergonomics Society. Ergonomics was the European term. The basic distinction, if you want to make one, is that ergonomics is physical, mechanical considerations, human factors more cognitive, visual, perceptual type things. Some people simplify it, they say neck up and neck down. But there's overlap. And I want to encourage you guys that there's overlap in this and what you do, and in what you do in your classes. If it's just a warehousing class, it still has overlap with manufacturing. And how does the product come in, and these sorts of things. And I always teach my students, I look for connections between the classes. I think the learning is deeper when you do that. So this is, in my world, ergonomic injuries and incidents are of 3 types. All right, we've got one is cumulative trauma disorders. That's overuse, this sort of thing. They have the best public list, because you always hear about carpal tunnel, low back pain, these sorts of things. But there's also these acute strains, sprains, pulls, and traumatic injuries. Let's say I'm a worker and I go in and I'm doing a project at a house, and I don't want to get the proper wrench. So I use the wrong one and it slips and I hurt myself all at once. We kind of lump safety in here a little bit too, although safety kind of floats in all of them. And the last one is this human factors incidents or system failures like, holy cow, I pushed the wrong button. Now all of these are modified by environmental factors, and they affect both physical and cognitive functions. Heat, cold, vibration, stress, whether mental or emotional, or context stresses, you know, how I touch or how I interface with the product. Does the product have handles? How easy is it to grip this product, for example? Lifting in a cold environment. Packaging and palletizing in a blast freezer at like a food processing plant is a lot different. You've got limits on how long a person can be in there. And their likelihood of injury goes up. Like I said, I'll go pretty quick on a lot of these. In my world, I break everything down into 2 root causes: design and procedure errors. Design errors are things that make a difficult or confusing system, high forces, these sorts of things. Procedural errors, it's a non-optimal way to do it. Now, of course, there's overlap, because a bad design could lead to bad procedures, right? But you can virtually always track yourself to a human factors contribution to your accident. Something went wrong. Why did that forklift driver do that? Why did he try to carry all these things? There's some incentive. Are we rewarding this unsafe behavior somehow? And we'll talk about what I call the cost of compliance. Cost of compliance. So you have a 5-page manual for a ballpoint pen you just bought. Are you going to read that, or are you going to click the pen and start using it? And if we're asking workers to do that, we're asking for trouble. So cost of compliance we want to keep low. Make it easy to do it right. How many people have just bought a product in the safety? And I'm a safety guy. And I'm like, okay, and I read it all before I do it. I got a chainsaw. I'm going to read that. But other products, like I got 8 pages. This is a clock radio. Why do you have all this stuff? Make it easy for people. Get the essential information to them. So we're going to do the 10,000-foot flyby in physical ergonomics. Very quick overview of some of the risk factors. And this is review. You guys know these things. I will try to give you guys some tips that I like to use to teach these concepts to students, I think, to reinforce these things. So the big 3: force, posture, repetition. Repetition's kind of a catch-all. It includes also long durations or static postures. Those 3, modified by environment and personal characteristics, really are what are driving our physical ergonomics. In here, we have the effect of the force is a function of the muscle groups being used. So I like to do a demo. Now, Alice wasn't here. I was going to have her do this. I was going to have her squeeze this, and I was going to tell her that the occupational safety group went over on their budgets again and see how much she squeezed. But I'm going to see who's stronger. All right, so can you pinch this? Let's see what you got. See what you got. Okay, so